Hello, in this video we want to solve this question. A person's utility from wealth. A person's utility from wealth is given by U equals to under root W. U equals to under root W. This is the utility function of the individual. The person holds an initial asset of rupees 50. His initial asset is rupees 50. She accepts the gamble when she wins rupees 31 with probability 2 by 3 and loses rupees 14 with probability 1 by 3. What is her expected utility from gamble? What is her expected utility from gamble? This is the part 1 question. Part 2, what is the expected payoff from the gamble? Part 3, will she accept the gamble? Now first we do what is her expected utility from the gamble. Expected utility. Expected utility. What is the expected utility? Denoted by EU. This is P into U of W1 plus 1 minus P into U of W2. That is equals to P into U of W. This is the initial wealth plus change in W. That is she wins rupees 31 plus 1 minus P U of W minus U of W minus delta W, that is the change in utility, that is the individual loses rupees 14. We have to calculate this thing. P is given as what? 2 by 3 and 1 minus P is 1 by 3. W is 50. First initial W, I make it W1, W2. W1 is wins 31 and delta W2 is 14. This is your 2 by 3 and utility function is under root, that is 50 plus 31 plus 1 by 3 under root 50 minus 14. This is your 2 by 3 under root 81 plus 1 by 3 under root 36. 50 minus 14 is 36. 50 plus 31 is 81. Now the square root of 81 is 9. We are taking only the positive square root. This is 9 plus 1 by 3. The square root of 36 is 6. This 2, 3, 9, it comes 3, 3, 6, it comes 2, therefore 2 into 3 plus 1 into 2, 6 plus 2, this is rupees 8. This is 8. This is 8. The expected utility is 8. 8 units. We have to write the units. The expected utility is 8 units. Now part 2. What is the expected payoff from the gamble? Expected payoff from the gamble? Expected payoff. This is P into W plus delta W1 plus 1 minus P into W minus delta W2. This thing, that is P is 2 by 3. This is your 50 plus 31 plus 1 by 3, 50 minus 14. This is 2 by 3 into 81 plus 1 by 3 into 36. This comes 27, 36, this comes 12. Therefore 27 into 2 is 54 plus 12. 1 into 12. This is 54 plus 12. This is 66. Rupees 66 is the expected payoff. Then expected payoff is rupees 66. Now the part 3. Will she accept the gamble? Now utility function is given as u to the power half or under root w. It can be written as u to the power half. Now u prime w is what? I am making a first order differentiation of this utility function, that is the u prime, that w du by dw. This is equals to half w to the power minus half. This half comes here and half minus 1, that means minus half. This is positive and u w prime is d2u by dw square. U double prime is d of dw, the second order derivative, and du dw. This is d of du and half w to the power minus half. This minus half comes here, that is half into minus half, w to the power minus half minus 1, that is minus 1 by 4 w to the power minus 3 by 2. This is negative. That is the second derivative is negative. That means what? The individual is risk averse. The law of diminishing marginal utility holds. Law of diminishing marginal utility holds for this individual. Therefore, the individual is risk averse. The individual is risk averse. Since law of diminishing marginal utility holds for this individual, the individual, she is risk averse. She is risk averse. Now, without gamble, utility u equals to under root w, and without gamble his initial wealth is rupees 50, that is under root 50. If we take the root over of 50, it becomes 7.07 units, and the expected utility with gamble, we have calculated this expected utility with gamble. In the part 1 we have calculated this. This is your 8 units. Now, since expected utility with gamble is greater than the utility without gamble, she will accept the gamble. She is risk averse and the expected utility with gamble is greater than the utility without gamble. She will accept the gamble. This is the answer of part 3. I hope everybody understood the answer of this question, part 1, part 2, part 3. That's it for this video. Thank you.